I gotta touch it now. Okay, so I'm gonna talk about Git. This is Git or How I Learned to Stop Worrying and Love the Code. Anyone the reference? Anyone got it? Okay, good. If not, I don't care. Anyone use? Let's raise your hands. People who have heard of version control system before. And I'm just going to bring them down. Who's heard of? Out of all those people, okay. Out of all those people, who's heard of Git? Okay. And who has used Git? All right. So there's still a few people that might take something away. This is a talk on version control, but specifically about Git. But the general practice in version control is you make edits to your files, then you in some way you commit them to a version. So it's changing all the time, but at some point you decide that this is a unit of work. It's a little bit. What question?
We're talking about like the version control between like JDK 6 and JDK 7.
No. So not exactly versioning of software. That you can fit that into the version control. But I mean when you're developing software. Let's say you start with a blank slate. You have nothing in your directory. Then you add the main file that starts your program. Then you'll commit it and say initial commit. Then you'll add a feature. And then that's like a working program again. You commit it again. And then let's say you're working on it and it's all messed up. You can roll back changes to whichever commit you want. So you can take a look at previous versions and things. The idea is once you have a version control system in place, you don't have to worry about any of these things. So you don't need to worry about having a history. So you don't have to you don't have to keep like copies, like multiple directories of the same code all laying around. You just keep one repository and you have a full history of everything you've ever done. Correctness. So if you're working on it, you can play around. You can do anything. You can completely wreck everything, and you can always start fresh from any commit, like your last commit. And integrity. This is less advertised in a version control system, but if you just have a directory on your hard drive and maybe you're not even backing it up anywhere, how do you know that your files haven't gotten corrupted in the meantime? In Git and then in some other version control systems, there's checks in place to make sure that your tree, the integrity of your tree, and every commit you've ever made, so it never changes. So you know, and if it does change, you know it's changed. The one thing that it doesn't actually set Git apart, but when it was created, it kind of set it apart, was that Git is distributed. And it won't mean anything if you've never heard of version control, which is a lot of people here, but a lot of version control has one repository, and everyone is always on the network, and they're always connected to it. And this is a problem if you want to work on code when you're not on the network, or you just want to work on something locally, and you don't want to make a whole, you don't want to set up a whole server just to do your version control. In Git, everybody has a complete copy of the repository at all times. And complete is a bad term because you can have slight differences, but if your root is the same, and if a certain portion of your tree is the same, so if you're working with someone, you can merge and you can grab pieces from each other, so you can collaborate. So beyond just having, beyond just having local version control and all those things, you can actually work with someone else, even remotely. They could be 10 other people, there could be multiple dev teams working on different features all at the same time, and yet it all comes back together because you can have, you can merge and you can pull little bits and pieces from each other. So I'll talk a little bit more about the distributed part later. Where it came from, this is not the first version control. The idea of versioning files has gone back quite a bit further. One of the problems with the Linux kernel originally was they didn't have version control. So all they did was when you made a change and you wanted to submit it to Linus, you wanted to get it into the main tree, you would diff your original file from the main line of the kernel with the edits you've made, and you'd send a patch. And then somebody would apply that patch and look at it and see if they liked it. And if they did, they would just put it up on FTP, and that's the new version of Linux. And that was fine when you had a few people collaborating. And then it just grew out to the point where it was almost impossible to work that way. When thousands of people are contributing to something, just sending, there's no organization. So Linus turned to non-free. It was a proprietary versioning control system. And the gravy train derailed when he had a dispute with the developers of that version control system. So he couldn't use that anymore. But he wasn't allowed to go back to patches because everyone was done with sharing tarballs and all of that crap. So they decided, or Linus decided, he was going to write his own version control system. So he's writing a kernel. Why can't he write a version control system, right? So he laid out his criteria, and these are from Linus. It needed to be fast, it needed to be simple. So simple doesn't quite mean in usage. It means the architecture of how he made the version control system and the program itself need to be simple. But it ends up being pretty simple usage too. Nonlinear development. So most version control systems in the past, you couldn't branch and have multiple people working at the same time, really. You always had one main line, and a branch was a big deal. So you couldn't have one team working on this feature concurrently with another, and them all committing at the same time. It became a mess. In Git, it's very easy, and in fact, it's encouraged in almost every usage of Git, even if you're just working for yourself. It's very distributed, so like I said, everyone has a full copy. So even if you're on a train that has no Wi-Fi out in freaking Adirondacks or something, you can work on the code, and when you come back, your tree is only slightly different, and all you do is merge your changes back in. So you don't have to worry about being connected just to work on your code, and all the benefits still apply because you can commit locally. And it handles big projects. So the kernel is a massive project if you look, and yet you can still download it in a matter of seconds or maybe minutes for the first time. And then all of your commits happen instantaneously because they're all local. So an overview of how Git works, kind of. Everything is local until you want to share stuff. So you commit locally and you have your full tree. You have a full server, basically. And then when you want to actually tell someone about it, you just push it somewhere, and then they can look at it and pull from it. It's very simple in the way that it manages changes. So you have deltas, so you can see how a file has changed, but it doesn't store it that way. So it's not complicated. Just when a file changes, it takes a full copy of the file, and it's easy to understand. And the integrity comes from the way it addresses objects. It takes a hash of it. So if the file changes or if the hash changes, you know. So there's no way for a corruption to enter the tree, which is a big deal when you have 20,000 copies, or however many developers there are, thousands of copies of a tree. You want to make sure all of them are not corrupted. And this is a big one. When people start using Git and they use version control, there are some commands that try and alter history. So you might go back and you might delete a commit, basically, or like gloss over it, or you might amend a commit so you change it. The nouns we use to describe it and the verbs we use to describe it make it sound like you're actually changing it, but you never change a commit. Once a commit is done, it's a sealed thing. So don't be afraid to make changes and play around, because there's never a time where you can't get back. And there's a minor exception to that, but I'll get to that. But that's not something to worry about. So if you're working without version control, all you have is whatever directory you're in and just a tree. So you just have your files. That's over here. And so if you weren't using version control, you wouldn't see these right to. The way Git works is when you're working over in this left one, it tracks changes between yours and the bleeding edge of your tree in the Git repository over here. And when you want to commit something, what you do is move it from the working directory into a staging area. And this is actually kind of confusing. There's like 5 different names for this. You can call it a staging area. Some commands call it an index. Some of them call it cache. But it all means the same thing. So you're staging your file to be committed, and then when you're ready to actually seal them all up and put them in a commit and add it to the tree, you just commit it. And if you wanted to, let's say for the first time you wanted to work on something, you can take this tree and check it out into your working directory. And if at any time, let's say you wanted to switch to a different commit, so you had 20 commits and you wanted to go back a month ago and look at how your working directory worked, you could tell it literally to reset the working directory to the state of the Git repository at some given time in the past. So it's really powerful to look back at what you had done. And if there's a bug that was introduced, you can look to see exactly when it was introduced. There's a lot of nice things you can do there. Yeah. Oh, so.
Is there a way to view your Git repository from just terminal?
Yeah, I'm getting, so I think, well, yeah, here we go. So this is the complete guide to Git. You just look at the manual page, but that's not what you want here. These are the big guns. These are the things that you need to know to use Git. And actually, this is probably an extended list. You really need to know a few subcommands, and you can work pretty efficiently in it. And so I should explain why they are prefixed with Git. So the way Git is built is there's one small kernel in the middle, basically, that's Git, and it has subcommands. So you'll type Git, and then you'll type the subcommand for what you want Git to do. And so there's like maybe 60 different actual executables that Git is comprised of. Yeah?
Does every one of those commands have a man page?
Yes. Instead of having a space here, if you put a hyphen, a dash, you can use man here to get a manual page for any of these. So if you forget what one does, or you just want more options and you want a more in-depth explanation than just like this little thing I got here, put a dash in the middle and put man at the beginning.
So man git clone.
Yeah, man git dash clone will get you the full, it has great documentation. Git is notoriously good for having complete documentation. So you can learn just by reading man pages. That's why I said here, if you start here and then just follow all the links they give you, basically, you could probably learn it. That's not a good way to do it, but when you start, so if you had an existing project you wanted to put under version control, you wanted to start a project, just do git init. And if you're in the directory you want, it'll just do it there. You can also put where you want. I think you might have to supply the current directory. So like git init dot will start a git directory, start a git repository in your current directory. Or if you don't have anything yet, you can pass in the name of the project and it'll make a directory for you and it'll fill in all the stuff. So git init when you start. So that's you can look that up each time because you only do that very infrequently actually, unless you have a lot of projects. But if you are looking at somebody else's code and you just want to start where they are currently, you can use git clone. So that takes somebody else's git initted and you want to get a copy of it where it is, you just say git clone, it pulls the whole tree over and you have a full copy of it. Some of these branch you'll get to, you'll have to branch at some point, but that's less important. If you want to, let's see, if you want to see the current status, so if you want to see what's the difference between my working directory and the actual git tree. So what have I done since the last time I committed? You'll say git status. So you'll be checking that quite often because you might want to know. That'll tell you what's in your index. So you could ask the question, what would be put into a commit if I did git commit right now? That'll tell you right there, git status. So that leads to git commit. If you have something in your index that you want to make a commit out of, you use git commit. So all of these are pretty straightforward. I don't want to just bore you with a list right now. But I think I've got, yeah, so I may need actually to scroll down into this one, so I might need to run back real quick. But this, oh, okay. So this might be, this is a common scenario for what you got to do. So if you, oh, is there a down arrow? Yeah, it doesn't do anything. No, good. So go back up a little bit. I'll just tell you when we need to scroll. So if you were going to make a project foo, you're working on foo. Make foo and you change into foo. So you're in foo. Now you initialize a repository in here. And what that actually is doing is making a directory called .git, which is hidden normally. .git in that directory. And Git knows it's a repository because there's that directory. So if you look in there, you can see all the guts, all the internals, but that's not important. You don't need to look in there. Just know it's making that. If you do git status immediately on a clean repository, it says you're on the master branch. So that's going back to the branching thing. Initial commit. Oh, I think it's just because it has a, I must have had history in here. I don't know. Initial commit must mean that I don't even know. Initial commit must mean that it's a entry repository. But it's saying there's no files that are in the working directory that are not in the current tree. So if you make a file right here, so I made bar, and then you check status, and you go, yeah. Now it says these are in your working directory, so these are untracked. These are in your working directory, but I've never seen them before. I haven't even seen them in the tree anywhere. You haven't even modified this, you just made it. So it even tells you, most commands will, it tells you exactly what to do at this point. If you wanted to add this to a commit, you would use git add file to include in what will be committed. So it puts that in plain English for you on most commands, so especially status. So you do just that, git add bar, then you check again. Now it's in that middle column, so it's cached. So it will be in the next commit if you don't do anything else, if you commit. And it even tells you, see here, they refers to it as a cache basically, but you could also call it the index, or there's like 5 different names, so you just might need to look up these things. But you could remove it from the cache. So it says exactly if you want to unstage it, and so it won't be in the next commit. But if you do want to commit it, you can just commit right here. So git commit, and you give it a message. And then if you scroll down a little bit more, it says who you are. So I'm Scott, I'm committing it. It says what's happened. So it gives you like a little like diff of what the commit does. So I've added a file. I've changed one file. And now you can check the log. So you can get a full listing of all the commits that have happened. And in this case, there's only one now. And the message was initial commit, so it shows up here. And it gives you all this nice metadata. And if you did this again, you'd get another one. I think I go into it more later, but this is just the beginning. You can do things like branching. So you would have a bisection, but you'd have an intersection where one one section of work did one thing and another did another, and they conflict kind of. So you'd have to merge them back together. So one nice thing about Git is it doesn't get too clever when it comes to merging. So if you do have a conflict, a real conflict with someone, it'll just mark where the differences are. And you just go in with an editor, you fix the things that are conflicting, and you continue committing, and it tells you exactly what to do when you have a conflict. And then you just go on with your way. There's a couple different workflows, and you might get, I might get into that more a little later, but this is just an intro. If all you did was edit files, add all the files, commit, you would at least have a history of everything you've done at whatever granularity you want. You could do it every time you changed a line, and then you'd have a ridiculous number. You don't want to do that. But if every time you added a feature, let's say you're working on homework, and you start out the repository and you make all the blank files, say initial commit. Then let's say you implement foo. That's one part of the project you have to do. Make it out of the files, git commit, implemented foo. And then you can go down the list and see everything that you've done. And if you have a problem with one of them, you can jump back to it. So even if you just do this and you don't share any commits, it's a great help. This might be going a little too far in depth, but the idea is Git does not change a commit. Once a commit ends up in that repository, it's always there. And I'm lying here a little bit. After 30 days, if you didn't ever delete a commit that was unreachable, the directory, the repository size would grow really quickly. So what it does is every 30 days, if you run a command, it runs a garbage collector and deletes stuff. So as long as you don't want to go back to a commit 30 days later that you've deleted, you're fine. You can always get it back. So don't be afraid to do crazy stuff. And the tool that you would use to get back a commit if you somehow lost it, like if you looked at your log and you noticed that a commit you wanted was now no longer there, you committed and it's not there, you could use reflog. And it would give you a list of all the times it was there. And then you would just jump back to it. And so you could see it again. So you haven't lost it. So once you have a tree, let's say you were working with a buddy on it and you wanted to share changes. The nice thing is everyone has a full version. So you might make an intermediary repository where you push and pull from. And so you can both work on it. One of those places is GitHub. And we're trying to get more people on our GitHub. We have one for just the club. So if you're working on code within the club, you would make a repository. And then you can take your tree and any changes you have and push them to the repository. And then everyone else can see them. And if they want to get those changes, they can use pull to grab all of your changes. And then you can work and you can collaborate on stuff. Yeah.
If we wanted to, could we host our own GitHub on?
Yeah. So the thing that a lot of people don't realize is GitHub isn't special in any way. The only thing it does is when it makes the directory, when it makes the Git repository, it adds a special flag saying no one's going to work on it here. I'm just going to be an intermediary between people. So that allows you to push changes to it. So you overwrite the working directory in someone else's repository, they would get mad. But in GitHub, or if you wanted to host your own, you just tell it specifically, this is an intermediary. No one's going to work on this copy. We're just using it to collaborate. So that's called a bare repository. But you don't need to know that either. Just know you can go to GitHub. We could make our own, but we're just probably going to use GitHub for now.
Can we all get actual access privileges?
Yes, we need to be better about that. But we'll get on that. And then so if you do have a GitHub or if you want to make a GitHub, we'll definitely get you right on there and you can start working on stuff. This is kind of how I wanted to sum up. I could go in a little bit more depth about workflows, but that comes with time, and that's really based on the project. So if you were just having a straight linear thing, you just had one branch, and it just went, every commit, you just added it to the branch, you don't really have very much organization. And the problem comes when multiple people are working on different features that might conflict at the same time. They don't want to constantly be merging each other's changes. So what you can do is, and I might draw this up here, if you had a root down here, everyone starts out at the root of the tree. It's the only one that doesn't have a parent commit. Everything else points backwards somehow. So this is the initial commit. I might need to. This one's crap. Actually, I don't know if that's any better.
No, not at all. Okay, do we need to turn on light for a second?
This is the end. This is the last one, but so I can just talk about it. But okay, that work?
All right. What is this? I forgot.
With what?
What does this dot represent? Stringy, tell me.
Okay, so this is the root commit. So if the first time when you have whatever in your directory and you say git init dot, you add everything and you make the first commit. It's a special case because there's no parent. So you can't go back any further than this. This is the beginning of history. Now let's say in that example, all I did was add bar, and then I just got a straight line up to here. So this commit is add bar. This is a crap. This adds a file. Now let's say you had a repository somewhere, you took this whole thing and you pushed it out there, somebody else pulled it, and all these terms are the names of the commands. It's git push and git pull. You push this out to GitHub, somebody else pulled it, so basically there's a second copy of it up here, and these are two different users. And then let's say you wanted to work on feature A, and they wanted to work on feature B. You might take this commit as your root, and you might say, make a branch called feature A, and start committing to it. And then they might make a feature branch called feature B. Now let's say they work for a little bit, and you work for a little bit, and maybe you touch some of the same files. So if you wanted to right now, you couldn't just merge all the files immediately. You'd have problems. If you were doing this in a line and both of you were pushing, each time one pushed and then the other one had modified the same file, you would have to have a merge, and it would be a pain because you would constantly be fighting for each other over this one file. Instead of all working in a straight line, you want a branch. So then if you push this and then they push this, out in GitHub somewhere, you would have both right at the same time. So it would look more like this. And both of you can switch to whichever branch. So even if someone's working on feature A, they could check out this whole thing and then switch to feature B and work on feature B even. And at the same time, they could both be working. And they could all touch the same files. Now let's say feature A is done, and they want to get it into the main line here. There's two different methodologies here, and people fight over it, just like any good triviality. But you can either add a merge commit right here, so it's in the main line, and you merge it back into master. So these are branches. These are like master, feature A, and feature B. You can check out master, and then you say git merge feature A. And then if you haven't made any more changes to master in the meantime, it'll just do it automatically. So that's easy. Then let's say feature B goes a little further, and they're done. Now they want to merge in. But you'll notice these trees, they don't have the same root. Things have happened in master since this one took off. So there might be a difference here. So there's two different ways you can solve this. You can either make another new merge commit and merge off of this one, or you can do some git magic and you can say rebase. And you'll take the first change, so the first difference, and you'll point it up here. And you'll still have to merge. The difference is, in the first case, the person who does the pull has to do the merging. So the person maintaining master has to do the merging. In this case, the person that's working on the feature can do the merging first. And then when they send it back out, they can tell the guy, all these changes are clean. And then when he merges it, it just fills in like this. Or you could still have a merge commit. So you could rebase this onto here and then still have a merge commit here. But it won't offload the work from the maintainer of the repository to you. So what I'm trying to say here is branches help you keep off of each other's specs while you're working on stuff. So if you go to an open source project, for the vast majority, they will tell you you need to fork the repository because they don't want you to have write access to the main master. So what you're doing is taking a full copy that git pulled, a clone, I mean. You'll take a full copy of the tree. You'll work on a feature branch, and then there's a concept in GitHub called a pull request. So you'll ask, let's say you haven't done this yet. You will ask politely for the person maintaining master to merge in your commit. So you'll push this whole tree. They will only have up to here. You will say, can I do this? And they will say yes or no. And you can keep working in the meantime, and then when they're ready, they will merge it completely. And then your feature shows up as master, the next commit in master, on the main one. So the idea is everyone can collaborate without stepping on each other's toes, and the main master maintainers can control who actually submits code, what actually gets included. So that is basically the workflow of every open source. Everyone has their own quirks, but They may ask you to rebase, they may ask you not to. You'll have to learn those things, but those aren't so critical. So I think that's all I've got, basically. It's a quick introduction. Does anyone have any questions?
I do, actually. All right, so on your previous drawing, when you had, what was it called, relog? Or what was it?
Reflog?
Reflog, that's what it was. So when we were working on feature B, and we were drawing from those core files, and then like, all right, well, let's just look at a reflog of point in here. Those original files, I mean, if you're building feature B off of those original files, how can you just move them to the top? I don't really understand that.
Well, so they're always there.
But I mean,
there's a difference here to here,
right?
And that's all that Git tracks really is differences. If it sees a file has changed in this branch, you have to somehow consolidate the two. So if in the meantime nothing has happened, it knows that it can just copy the new one. It can overwrite completely because all the work that you did here has not conflicted with anything else yet. So it just takes your new version and just puts it over the old one. If there was a change, so like in this situation, right here, this one, it knows that there have been, there's only been changes in this one since here, but there's actually been another change here. So if it just took all of these versions and copied them right over and overwrote everything, you would lose something in here. And it's smart enough not to do that. So it'll tell you there's differences, you need to manually do this. So it'll either tell you that you need to rebase so that this one looks like you started working here. So you're kind of rewriting history, but remember that it makes new commits. So you can actually get back to this state no matter what. So if you do the rebase, it'll make a whole new branch basically, pretending like it started here. And then we know already, if there's been no changes since the one it started at when you branched out, it'll do it automatically for you. So that's what rebase is, and that's what merge is. Did I answer, or is I complete? Okay.
Thank you.
Yeah.
Questions one, questions all.
If anyone wants to see like an actual session of doing it, you can just pull something on our GitHub right now, and we could go over the actual workflow that we would use, like the website or something. But this is just like an overview of like the high level stuff. But
Questions? Give me 8 seconds. Room of silence. No questions.
Is the PowerPoint going to be on the wiki?
This entire video of him speaking will be somewhere accessible, probably on YouTube.
Okay.
You can go.